Today we're going to be talking about radicals and rational exponents. So to start off, a radical expression is a square root, cube root, fourth root, etc. So something like the square root of 3, the fourth root of 7, the cube root of 9, so on and so forth. So the index is the little number that's in the crook of the radical. So that would be like the 4 or the 3. Those are considered to be the index. And the radicand is what is underneath the radical. So the 7, the 3, the 9, that would all be considered the radicand. So a radical expression is said to be in simplest form when the radicand has no perfect nth root factors, the radicand contains no fractions, and there are no radicals occurring in the denominator. So we'll start off with a few examples here. Hopefully, for example 1, you recognize that the square root of 144 is 12. And then since we're dealing with a square root, you should also recognize that the square root of b squared is just b. But if you square a positive number or a negative number, the result is always going to be positive. So we're not sure if b started off as a positive number or a negative number. So therefore, we need to put b in absolute value signs. So the answer to example 1 is 12 times the absolute value of b. For example 2, because these are separated by a minus sign and a plus sign, we are not able to remove the 4's or the 1, or the m squared for that matter. So what we have to do is factor this guy first. So hopefully you recognize from the other day that this is a perfect square trinomial, and it factors into 2m minus 1 times 2m minus 1. So we can rewrite that as 2m minus 1 squared. And now, since the index and the exponent are the same, we are allowed to remove the 2m minus 1 from the radical sign. Again, since we're dealing with variables, we're not sure if that quantity, the 2m minus 1, was positive or negative to begin with, so we need to put that in the absolute value sticks. So the final answer to this example is the absolute value of 2m minus 1. For the third example, the cube root of negative 125a to the 12th, first of all, you are allowed to have a negative because it is a cube root. So anytime it's an odd root, you are allowed to have a negative underneath. If you recognize that 125 is a perfect cube, that's great. If not, you should make a factor tree. And so you want to break 125 up into its prime factors. So you would start with 2, but 2 does not go into 125, so then you could try 3, which also doesn't work. So the next prime number is 5, and 5 goes into 125 25 times. And then 25, you know, breaks down into 5 and 5. So you count up the dead branches on your factor tree. And so that tells you that you can rewrite negative 125 as negative 5 cubed. And then you still have your a to the 12th there. So again, since your index and that exponent are the same, that means the negative 5 gets to come out from underneath the radicand. As far as the a to the 12th goes, you could ask yourself, how many times does this 3 go into 12? And that answer is 4. So that comes out as a to the 4th. Since we're dealing with an odd root, we do not need to use absolute values on the a to the 4th.